From the grade 11 November 2015. Question 5. In the diagram below, the coordinates of P are x is to 24 is a point such that OP is equals to 25 and ROP is equals to beta, where beta is an obtuse angle. 5.1.1. Calculate the value of x. So we just have to extend that and we form a right angled triangle. So x squared plus y squared is equals to r squared. X squared, that's what we are looking for, and then y is 24, and then r is 25 squared. X should be equals to the square root of 25 squared minus 24 squared. So I'm getting a minus 7. 5.1.2. Determine the value of each of the following without using a calculator. A, so sine of beta. So sine is opposite over the hypotenuse. So the opposite is y, which is 24. The hypotenuse is 25. Then cos of 180 degrees minus beta. 180 minus is in the second quadrant. In the second quadrant, cos is negative. Cos is x over r, and our x is minus 7, our r is 25. So this becomes 7 over 25. C, tan of minus beta. So here you just add a 360 there. So this is 360 minus beta, which is in the fourth quadrant. In the fourth quadrant, tan is negative. And then tan by definition is y, which is 24 over x. So this is 24 over 7. 5.1.3. T is a point on OP such that OT is 15. So we'll create another right angle triangle there where OT is 15. Determine the coordinates of T without using a calculator. So now we have two triangles. We have the big triangle, which has this is 25 minus 7, and then this is 24, and we have beta there. We also have the other triangle. So this is TO, that's 15, because that beta right there is going to be common for both the triangles. And then we only have those sides. So now let's try and calculate this vertical distance. So we'll just use sine for both. So sine of beta, in this first triangle, beta will be sine will be given by 24 over 25. So this is 24 over 25. And then sine in this triangle will be given by the YT divided by 15. So YT should be equals to 24 times 15 all over 25. So I am getting 72 over 5. And then now we can go on and calculate this x value right here. And then we'll just say x squared plus y squared is equals to r squared. X, that's what we are looking for. The y is 72 over 5, 72. And then this is 15 squared. So the x should be square root of 15 squared minus 72 over 5 squared. So I'm getting 21 over 5. But the x must be negative there. This means that the coordinates of t must be negative 21 over 5 is 272 over 5. Let's try a different method. So we have these two triangles. Okay, that is a 90, that is a 90. So let's just, this will be triangle PO, and then we'll designate that as K. And then we'll give this point right here, let's just say it's a D. So we have two triangles. So we'll say triangle is similar to triangle. So this K will be equals to the D on that side because they are both equals to 90 degrees. So this will be a K and this side will be a D. And then O is common in both of them. They are both equals to beta. So this is O, this is O. This means that P must be equals to T. P must be equals to T. And then we formulate a ratio. We'll say KO over DO. So this is KO over DO. And then OP over OT is equals to OP over OT is equals to, then we take the first and the last. So this is KP. Same thing, D and T. And then we just check our triangles. OK we do have. And then DO we don't have DO. OP we do have. So we'll just tick that off. And then OT we also have OT. So we can calculate DO. So this is KO over DO is equals to OP over OT. By the way, the reason for this is angle, angle, angle. So KO, what is KO? Minus 7. So that's minus 7. And then DO, that's what we are looking for. OP is 25. And then OT is 15. So OD should be equals to negative 7 times 15 over 25. So I am getting minus 21 over 5, which is the same as that. And then you'll just use the theorem of Pythagoras to calculate the vertical distance, and you should get 72 over 5. 5.2. Determine the value of the following expression. We are given 2 sine x multiplied by cos of x, 1 plus tan squared, and then this is tan x. So this is 2 sine x multiplied by cos of x. I'm just gonna solve the thing in the brackets just on the side. So this will be 1 plus, and tan is given by sin squared x over cos squared x. And then this will be cos of x, there's a squared there, squared, plus sine squared x all over cos squared x. So that's what I'll be left with inside of there. This is cos squared x plus sine squared x all over cos squared x. This is sine x over cos x. And then this is 2 sine x cos x. We know that cos squared x plus sine squared x is equals to 1. So that's 1 cos squared x. Then we're just going to divide, okay? Let's just fix this. This we are going to divide by sine x over cos x. So I'm just going to change this to a multiplication sign and then flip that. So this is cos x over sine of x. So we can see that this cos x will cancel one of those. That one will cancel the other one that's remaining. Sine x is on top, sine x is in the bottom. So this should be equals to 2. 5.3. 1 minus cos squared a all over 4 cos 90 degrees plus a. Simplify the expression to a single trigonometric term. So this is 5.3.1. 1 minus cos squared x is equals to sine squared of a. Because remember, sine squared a plus cos squared a is equals to 1. So this is sine squared a is equals to 1 minus cos squared a, which is equals to that. So this is over 4. Cos 90 plus is in the second quadrant. In the second quadrant, cos is negative. So we're going to have that negative there. But because we have used 90, the cos will change to a sine. So one of those will go with that. So I'll be left with 1 over 4, negative 1 over 4, sine of a. Then 5.3.2. Hence, determine the general solution of that. So whenever they use hence, it means that you need to use the solution from the previous answer. The solution from the previous question. So this is 1 minus cos squared 2x. This is 4 cos 90 plus 2x is equals to 0.21. So here we only had an a there. And we also had an a there. But here we have two x's. So our solution should be negative 1 over 4 sine of 2x, because we have 2 there. So this side is going to be negative 1 over 4 sine 2x. So we are using this because they said hence. We are using this from the previous question. So this should be equals to 0.21. So this is sine of 2x is equals to 0.21 times 4. So this is negative 0.84. So we need to work in the quadrants where sine is negative. Sine is negative in the third quadrant and the fourth quadrant. So let's find our reference angle. Arc sine 0.84. So I am getting 57.14 degrees. And then we are working in the third and in the fourth quadrant. So in the third quadrant, this is 2x should be equals to our reference angle. So when we are working in the third quadrant, we'll say 180 plus the reference angle. So this should be 180 degrees plus 57.14 plus k 360 degrees, where k is an element of integers. So this is x is equals to, so we'll say 180 plus 57.14, all that divided by 2. So I am getting 118.57 degrees plus k. Then we're going to divide that by, so this is 180 degrees. And then we move to the fourth quadrant. This is 2x, which is equals to, so it's 360 minus 57.14 degrees, k 360. So x should be equals to 360 minus 57.14 over 2. I am getting 151.43 degrees plus this is k 180 degrees.